So the election result is just a separate file on my GitHub site. So this is actually a very small file. So if you click open in CoLab, and then it's going to open up with another file. Just for so this is not official election result. I just got it from the internet. I didn't check the integrity of the result, just to make it clear. There's a lot of data set people put it on the website. This is just one of the data set I got. So if you want to modify the code, you need to save a copy of the code on your own computer, on your own Google Drive. So, okay. So this is someone put a 2020 election result there. So I got that one there. And this is also county level voting record. So we have Alabama, Autauga County, vote GOP, vote DEM, total votes. The difference, that must be the difference between the GOP and DEM. Then percentage of GOP, percentage of DEM, percentage difference. That basically is the data set. So once you have this, you might ask, what's the total number of votes? And we can just add up the total votes of every county, and that should be the total votes of the United States, right? So there, really a lot, 158.4 million. That's 433,557. Yeah, that's yeah. It's a good exercise just to read them out, I guess. 158,433,557. I guess that's the correct way to read it. Yes. Okay. So, and then we can ask, what's the percentage of GOP? What's the percentage of DEM? So, since we know the total, we just divide the votes of GOP, votes of DEM, and oh, that's just the total vote. We can actually divide by that. Let's say total.
Quick question about this data.
Yeah.
So it just says votes GOP or votes DEM or DEM. Is that like the registered party of the voter? Is that Biden or Trump? Like, because, right, people can vote for more than one person in an election. So I assume this is either Biden and Trump or.
I have no idea. That's what the data is. So I don't know. I would assume that's probably just for the presidential.
Okay. Yeah, that, I mean, that's where the numbers look pretty familiar from.
Yeah, good question. I don't know. I can go back to check the. Yeah, 51.29 something for DEM. 46.8 something for GOP. Really? That's a lot. I thought the difference was smaller than this. Did I do something wrong? Is that the official record? One was 46.8. Well, it's something that's the data, and what's the news report? I guess there's the official report. And then we can look at every state. But in this case, I'm to look at California. So pick California with the state name, which is California. And then we arrange it by the percentage of difference between the GOP versus the DEM. So yeah, even though California is the deep blue, but if you look at the county level, it's really a bimodal distribution. There's a lot of county vote to GOP. See, this is 0.6, 0.7. Well, there are some county even vote 75% GOP. So there's one county here. So yeah. There's a one distribution and there's also another distribution here. So yeah. So 0.4, 0.6, 0.5 here. So in fact, there's almost no state, no county is exactly 0.5. That's actually that is a value there. So so the result I got is by county. We can also tally those results by state. So here I select all the state, and then we use something called group by, and by every state, group by the state, I just summarize it. Summarize all the values there. So then we have a state voting record. So unofficially, that's just the data I got. So once we have that, we can calculate each state vote for GOP, percentage vote for GOP, or percentage vote for DEM, and then plot that one out. So here's the state percentage vote for GOP. There, that's the percentage. This is, I just plotted the percentage vote for GOP. This is a histogram. 0.4, 0.6, 0.5 is here. This actually, there are actually six or seven states is closer to 0.5. So that's clearly a swing state, I guess. So there, 6 and to 8 state, actually, in fact, 8 state closer to 0.5. 0.4, 0.6, 0.5 there. So that there are 8 state borderline of 0.5. So there's also one state has what? One, I have just 5% vote for GOP. Which one is that? Anyone have a guess of that?
Repeat the question.
There's a one state with just 5% of votes goes for GOP. Which is that state?
I guess Oregon.
It's actually not a state. It's a District of Columbia. But in the data in the data set is listed at a certain level with the state because it doesn't belong to any state, but it's part of the country. That's District of Columbia. So how do we find that one out? So we can actually filter percentage GOP less than 0.1%. That would be that state, and there. It's District of Columbia. So in fact, 5.9, 5.4% goes for GOP. So, and obviously that looks an outlier too. And so if you want to do a further analysis, you have to remove that one because it doesn't seem to be belong to the rest of the state. So, and usually when you want to do a data analysis, if you have a sample, there's also something that doesn't belong to the sample or doesn't fit with the rest sample, that will be called outlier. And it doesn't in this case, the outlier is based strictly a statistical sense, and this is a distribution that's just way out there. So yeah.
Can I ask a quick question?
Yeah.
Where did these statistics come from? Did you upload them, or were they in a package or something already uploaded, or?
This is that's this data set I read
Okay.
from. Someone posted on the website. Oops.
I teach civics and I would like to use this. I think that's pretty.
Oh, that's the one person U.S. county level election result. Oops. No. Huh. Oh, I see. I need to do this. Yeah, this person there. He posted a U.S. county level election result. Yeah, that's wow. It's actually really a lot of other things. Presidential result. I think that's that's 2016 presidential result. That's the yeah. But that said, I don't think this person is anything related to official. I think this is just the so-called open source. This is the United States election result by county from 28 to 2020. So it's actually how many turns are there? 8, 12, 16, 4 turns, 4 election results are there. So yeah.
That's great. Thank you so much.
Oh, sure, yeah. It also looks like the original code are Python. So this guy actually used Python to do the analysis. Yeah. Yeah, it's actually Python code. This is actually, yeah. He used Python to do the analysis. I just read that data here. I guess we can also use Python, but right now the code is in R. So yeah. There are so many data out there. It's yeah. So here and now I'm going to label the state by that called the deep red, swing blue, deep blue, and I just made up my own definition. I'm not sure whether that's even correct or not. So I'm going to call any state is 47%, between 47 and 53. That's the swing state. Anything off that would be blue. Of the 0.4, that would be blue. Of above vote for GOP greater than 0.6, that's deep red. You may have better idea doing that, but you can change the code if you like. So, and that's my criteria, and that's my label. So deep blue, blue swing, red, and deep red. And then we can label the state and see whether that result makes sense or not. Oh, actually didn't print that one out. State DF, yeah. So, okay, and you can look at the results, see whether it makes sense or not. Blue is Minnesota blue? Maybe not. Maybe that should be called swing. Michigan swing, Massachusetts deep blue, Maryland blue, deep blue, Maine blue, Louisiana red, Kentucky deep red. Well, is a simple cutoff. So Arizona swing, that seems to make sense. Alaska is also swing. Okay, that seems to be a bit troubling. But it actually does seem the 48. It seems to, yes, closer to 50%. So Alabama, Secretary, that deep red, that seems to make sense. California, deep, 34. Okay, that makes sense. Connecticut, deep blue, I guess so. Yeah. So, well, it's just a label. I mean, 47.8. Yes, I don't know. Yeah, swing. Anyhow, you can modify the data. Besides this, just 2020, right? So, okay, we can also get the census data, and then we can merge the census data with the election data. Now, the trouble is some state census and the voting don't use the same district. So if you want to merge the location of the election with the census data, you will see some state doesn't match. And that's Alaska. Alaska, for some reason, voting district and the census district are not the same district. I don't know how it happened, but apparently that's the case. So you cannot, so basically based on the census and the voting, you cannot do analysis. That's quite interesting how Alaska works. So I don't even know how they decide the votes there. So since census and the district are not the same. So okay. Anyhow, but that's the data. If you want to analyze them, once we merge the data, Alaska has to be removed because its voting and census doesn't follow the same location. So we cannot analyze Alaska. Once we merge it, and you can see Alaska disappear because it doesn't have a location there. So yeah. But now we have the census data, we can do so-called linear regression analysis, see whether the voting and the population has some correlation or not. It does not. Actually, I mean, you probably know the absolute population and the votes of GOP, it has no correlation. So we can even do the state, swing state. So that's also, oh, that actually has some correlation. It looks like a large state tend to be blue or something. But that Texas is also there. Hold on, let me see. Deep blue, that must be California and New York, I guess. So. But there's also a state with a very small population. It also tends to be a deep blue. So it's not a very good predictor anyway. So. But we can also get the area of the state. So this is part a student can learn how to merge a different data set. And this is basically the geographic area of the state. And once we have that, we can calculate the population density of each state. So here I'm calculating the population density of the state. And then I do a linear correlation. And this turned out to be extremely good correlation. Now the trouble is once you do the plot, you'll realize there's an outlier here. That's the District of Columbia. That's highly densely populated, and that seems to be a really outlier there. So usually when we do a statistical analysis, there's an outlier there and seem to be skew the rest of the data set. You need to remove that from the analysis. So this is a good, from my perspective, this is a good exercise for the student to learn how to properly analyze the data. If you want to see how the population density correlates with the voting records, you cannot have a data point which is so extreme, it's going to skew the result of the rest of the data point. So in this case, we have to filter that one out, remove the District of Columbia out of this one, and then redo the analysis. So here I'm filtering that one out. So there, then we redo the analysis. The good thing is after we filter the District of Columbia, this statistical correlation of population density and voting record is still there. In fact, it's a very, very, very good correlation. for any, if you want to use this bet for the stock price or lottery, you will have a good return there. So the population density and the GOP voting record. So apparently the more dense the population of that state, the less likely to vote for GOP. So this is that's the correlation there. So yeah, you have the p-value is, wow, this is extremely small, 1 out of 10,000, 1.7 out of 10,000. It's a very significant correlation there. So you can also plot the population density by the state label. So here we have the deep blue, blue, swing, red, deep red. Yeah, so there, deep blue tend to have a higher population density, deep red. You see also some of this overlapping, but overall, you can see this distribution is higher. This distribution is lower. So blue, now the blue swing and the red, actually they are more or less the same. So this is, even though it's highly significant, but doesn't mean it explains everything. So you also have a swing state that had a very high population density here. So and there are also a blue state with a very low population density here too. So, and we can also do a so-called a box plot, and then you actually see the distribution better than this the scatter plot. So once we do this, you can see that will be the median level, and then those are the range of the distribution. So the deep blue, the distribution certainly have a higher mean value there. Deep red, but the rest of it is all relatively low. In fact, the swing states seem to have an even higher one than the blue. So yeah, so this is actually not so. Population density seems to be a statistical correlation, but it's obviously not everything. Yeah, election is quite complicated. So. And we can also do a so-called t-test. Test the blue deep red population density with deep blue population density. I mean, obviously that's quite a significant difference there. So it is 9 out of 10,000 p-value here, so or 1 out of 1,000. So that's the very small chance this can be due to random. So. We can also do some data visualization here. So this is the population density by the state. By percentage of GOP, sorry. Percentage of GOP voting, and that's the state. And we can also order it by the state name. Well, District of Columbia obviously is here. It looks like a very extreme example here. And the rest of the state ordered by the increasing GOP votes. So Wyoming, West Virginia. Oh, West Virginia is here second. Wow, that's surprising. West Virginia, Oklahoma, North Dakota, Idaho, Arkansas, Kentucky, Alabama, South Dakota, Tennessee. Oh, Tennessee is here. So. Tennessee, Louisiana, Nebraska, Utah, Mississippi, Indiana, Missouri. I mean, you can read it on your own. So, and Vermont is the least GOP votes. Vermont, Massachusetts, Maryland, Hawaii, California. Well, California is actually not the the most deep blue one. Vermont actually is one. Okay, that's interesting. New York, California, New York, Rhode Island. Yeah, so that's the visualization of this voting 2020 voting. So I guess we have this 2020. If you compare with the 2016, 2012, 28, you can see how the state changed. It must be interesting to compare Georgia's, I guess, to see how that trend changed. Yeah, so if you in that case you have the Georgia voting record, you also have the census. Now the trouble is the census is every 10 years, so it's not every 4 years. So it's there. How do you do the analysis? A bit tricky. So yeah. Okay, so that's quite a lot. It looks like I already went over the tomorrow's data set already. So yeah, so tomorrow I can just go over your essay part. And we can also go back and review this, help you to modify your code. And for some of them want to do climate change, I can probably help you modify that part of the code and see whether we can do a bit more analysis there. So, questions? This is really a lot. It also goes much faster than I expected. So,